All right, in this video, we're going to be talking about probability, understanding what it is, and then we'll finish up by looking at working through some problems that we might see on the GED. So essentially, probability is just telling us how likely or unlikely something is to happen. It can be expressed as a percentage, it could be expressed as a fraction, or it can be expressed as a decimal. But all of these, in terms of probability, will have a value somewhere between 0 and 1. So if something is guaranteed to happen, right, that would be a 100% chance if we're expressing it as a percentage. 8 out of 8, 9 out of 9, 4 out of 4. Those all represent something that's guaranteed to happen, 100%, right, or 1. Or as a decimal, 1.0. Okay, all of these would mean something is guaranteed to happen. On the flip side, if there's a 0% chance that something's going to happen, it's impossible, right? And then it's sort of a spectrum, right, in between 0 and 1. So if something has a 25% chance of happening, well, right here in the middle is 50%, or 0.5, or 1/2, right? So 25% would be right here, and 75% would go here, right? 0.75, or 3/4, okay, 0.25. We don't need to know all of these, but it's helpful to just have an idea, okay, of this on the number line, essentially, right, of what these different probabilities mean. And again, this idea that we can express them in any of these three forms. Okay, so now let's look at the example of a bag that has 10 marbles in it. We can't see inside the bag. We're reaching in blindly and pulling out a marble. And I want to say, well, what's the probability that when I reach my hand in, I pull out a red marble? Okay, so let's talk about the basic concept of how we calculate probability. So when I reach into the bag, how many potential outcomes are there, right? I could choose any of the 10 marbles. So the total number of potential outcomes or possibilities, let's call it possibilities, goes down in the denominator, okay? And then the possibilities that I'm looking for or the possibilities that I want would go in the numerator. So when I reach into this bag, how many total possibilities or different outcomes are there? There's 10 different outcomes because I could pick each one of those marbles. Now, of those 10 marbles, how many are red? 6 are red. So one way we could express the probability, it's 6/10. But what should I do with this fraction? Right, we should always simplify. So actually, we would express this as a probability of 3/5. Okay, remember that I also said probability can be expressed as a decimal or a percent as well. If I did 3 divided by 5, I would get 0.6. Okay, so that's also another way to express this probability. And 0.6 is the same thing as 60%. So by that same logic, what would be the probability that I reach in and pull out blue? Well, there are 4 blue marbles out of 10. This simplifies to 2/5, or 0.4 if I divided, or 40%. Now, notice that because there's only 2 options here, right? If I don't pick red, I must pick blue. So when I add up these 2 probabilities, they get to 100%, right? This is very similar to saying, instead of saying what's the probability that I pick blue, I could say, well, what's the probability that I don't pick red? Okay, and the probability I don't pick red is just 1 minus whatever the probability is that I pick red, right? So if I know that there's a 6 out of 10 chance, right? And let's make this one 10 out of 10, right? Well, then the probability that I don't pick red is 4 out of 10, right? Another way to think about this, let's say I have a 90% chance for something to happen. Well, what's the percent chance that it's not going to happen? 10%, right? Together, they make 100% because when we have like all the total possibilities together, that's going to give us 100%. Okay, so now we're going to take a look at the example of a 6-sided die, right? So we roll the dice, there's 6 sides on it, numbered 1, 2, 3, 4, 5, and 6, and there's an equal chance that we land on each side, okay? So I could ask you, well, what's the probability when I roll that dice that I will roll a 1, right? I roll the die, what's the probability I roll a 1? Well, what's the total number of possibilities? There are 6 sides, so 6 is my total number of possibilities. And of those 6 possibilities, how many of those am I looking for? Just 1. So the probability would be 1/6. In this case, it's probably easiest just to leave it as a fraction. So what's the probability that I don't roll a 1? Right? Well, that's just everything else, right? So 5 out of 6 would be the probability that I don't roll a 1. Notice together, these add up to 6/6. Okay, but let's like combine a few different possibilities. What's the probability that I roll a 1 or a 2? Well, there's still 6 sides on my die, 6 total possibilities. But of those 6 possibilities, how many of them am I happy with? 2 of them, right? So 2/6. Or if we simplify that, 1/3. Okay, one thing I want to point out, the probability of rolling a 1 is 1/6, and the probability of rolling a 2 is also 1/6. So when we have a situation like this where it says the probability of 1 or a 2, what do we do with our probabilities? We add them up, right? 1/6 plus 1/6 gives me 2/6. So now let's talk about what happens when we're asked to calculate the probability of 2 things happening in a row, right? So you could say like, what's the probability that you roll a 1 and then another 1? So like 2 times in a row that I roll a 1 2 times in a row. So when we have a then situation, like the probability that first this thing happens and then that thing happens, it's called dependent probability, okay? Dependent probability, the name is not so important, right? But they like depend on each other, right? They both need to happen. And when we have dependent probability, when we have a then situation, what we do with our 2 probabilities is we multiply them together. So the first time that I roll the dice, what's the probability of rolling a 1? Well, there's 6 sides, and I only have 1 of those possibilities that's going to work. And the probability doesn't change the second time, right? The die is still the same. But instead of adding these 2 probabilities together, like in the previous example, we're going to multiply them, right? So the probability of rolling a 1 and then another 1 in a row would be 1 out of 36. So let's do another example. What's the probability of a 1 and then an even number? So again, it's a first this, then that situation. So we're going to multiply our probabilities together. What's the probability of rolling a 1? Well, that's still 1 out of 6. And what's the probability of an even number? We have 1, 2, 3, 4, 5, and 6. This one, and this one are even, so that's 3 out of 6. We can actually cross cancel here. And and we get 1/12, right? So the probability of rolling a 1 and then an even number would be 1/12, meaning it happened 1 out of 12 times, as opposed to 1 out of 36 times, right? So if we're trying to think about, well, which of these two things is more likely, this is more likely, right? This value is smaller, this value is closer to 0. Okay, so we're going to take a look at an example of a problem we might see on the GED involving probability. So here it says, you flip a coin twice and spin the spinner. What's the probability of flipping heads twice and then not spinning a 4? So how many different events are there here, right? There's 3 events. Event number 1 is our first coin toss. Okay, what's the probability of flipping heads? Well, there's 2 options in a coin, heads or tails. Heads is one of them, so 1/2, 50%. What's the second event that has to happen in a row? I need to do my second coin toss. Also has a probability of 1/2. And then what's the third event that needs to happen? Spin the spinner. It says not spinning a 4. So the 4 would be 1 out of 4, right? But that means I could spin any of these. So the probability of not spinning a 4 is the same as the probability of spinning a 1, a 2, or a 3, which is 3/4. Okay. Now, this was a then situation, right? First I need to flip heads and then flip heads again, and then I need to spin not a 4, right? So we're going to multiply our probabilities together. 1 times 1 times 3 is 3. 2 times 2 is 4. Times 4 is 16. So my probability that this would occur would be 3/16, 3 out of 16 times that I tried it, on average. Okay, we're going to return to our example of a bag of marbles to look at a specific example that might come up on the GED that can trip you up. So we just talked about dependent probability, right? How do we figure out the probability these 2 things happen in a row? So we're going to do another problem like that. So we want to know what's the probability that you draw a red marble and then a green marble. Okay, so, well, what's the probability when the first time I reach in, right, to the bag? How many marbles are in the bag? 4 plus 6 makes 10, plus 10 more. Well, there's 20 marbles in the bag. How many of them are red? 4. Okay, so now let's assume it happened. I have my 1 red marble out here. How many red marbles are left in the bag now? 3, because I took one of the marbles out, right? So now, when I reach in for that second time, how many marbles are in the bag? How many possibilities are there? There's not 20 marbles anymore. There's 19 marbles. Okay, and of those 19, how many of them are green? 10. So again, notice in this situation, because I'm taking a marble out of the bag, my denominator changes. The first time I drew, there was 20 marbles, but because I took one out, now there's only 19 left. Okay, that'll trip a lot of people up. Multiply, we can cross cancel. This becomes a 2 and a 1. This becomes 4/38, and we can simplify, divide by 2. We get 2/17. Okay, so that would be the probability that this happens. Now, you might get a very similar problem, but they would very specifically say, what's the probability that you draw red, put it back, or replace it, right? They might say put it back or replace it, and then draw green. Okay, so basically the same problem, but what's the only difference? This time, we're going to replace the marble. We're going to put it back in. So in this situation, all right, first time, reach into the bag. there's still 20 total marbles. 4 of them are red. Okay, but then I don't take the marble and set it off to the side. I put it back in the bag. So again here, what I'm now drawing green. Well, there's still 20 marbles in the bag because I put it back. 10 of them are green. Okay. So a 1 out of 10 probability of that occurring. Okay. So this is kind of a specific example, but I do know it's something that comes up on the test. So if they give you a situation like this with marbles or anything like that, and you're taking them out, pay attention to, are they staying out of the bag? In which case our denominator changes, or am I putting it back in, right? In which case our denominator would stay the same. Okay, we're gonna look at one last example involving a weather forecast. So let's imagine you look at the weather forecast. It says Monday there's a 20% chance of rain, Tuesday a 60% chance of rain, and Wednesday a 90% chance of rain. So I'm going to ask the question, what's the probability it rains all 3 days? Okay, what's the probability it rains all 3 days? Well, this is a situation saying, well, it's going to rain Monday, and then Tuesday, and then Wednesday. So we need to be multiplying our probabilities together, right? We already have our probabilities written as percentages. There's 2 ways we could do this. We could turn them into decimal values, 0.2 times 0.6 times 0.9, or we could turn them into fractions, right? 20% is 1/5, 60% 3/5, and 90% 9/10. Okay, and then we would multiply straight across. I'll go ahead and do the fractions. 1 times 3 is 3, times 9 is 27, 5 times 5 is 25, times 10, 250. Okay, we could also do it out as far as multiplying these decimals together, right? We could use calculator if we're allowed to on the calculator section, or we could just do it out here, right? 2 times 6 is 12. I'm going to move my decimal 2 spots, so that's 12 hundredths, so 0.12 times 0.9. Well, 9 times 12 is 108, and then 1, 2, 3 spots back. Okay, so 0.108, or a 10.8% chance, right? These two have the same value. So I hope that this was helpful as far as helping you understand what probabilities are, the fact that we can express them with percents, with decimals, with fractions, and then also, right, understanding whether we're going to be adding together our probabilities, like in a situation of this or that happening, or whether we're going to be multiplying our probabilities together. And remember, we multiply our probabilities together anytime they want to know what's the probability of 2 things happening in a row. Thanks again for watching, and I'll catch you in the next one.